At one point, military design stopped thinking about what works best and started asking how big is too big. There was a time when planners stopped focusing on flexibility and began to believe that size itself could solve problems. Today, we're looking at Heavy Gustav, not as a battlefield weapon, but as an example of what happens when scale becomes the main design goal. Number 8. Built for image as much as speed. By the late 1930s, German military planners were obsessed with fortifications. France had the Maginot Line, concrete bunkers, and reinforced underground defenses designed to survive everything short of direct hits from the heaviest artillery. So what do you build when no existing weapon can break what's in front of you? Germany's answer wasn't subtle. They didn't ask how to bypass fortifications. They asked how to smash through them. Heavy Gustav was designed to fire shells so large they could punch through meters of reinforced concrete. The shells weren't meant to chip away at defenses or slowly wear them down. They were meant to break through in one hit, collapsing underground structures that regular artillery simply couldn't reach. This wasn't artillery designed for flexible battlefield use. It was old-school siege warfare, taken to an industrial scale. The gun required fixed positions, prepared rail lines, and long setup times before a single shot could be fired. The gun wasn't meant to fight wars everywhere. But solving one problem by creating something this extreme comes with consequences. And those consequences didn't show up in combat first, they showed up in how difficult the gun was just to operate. Number 7. Size as a strategy. Heavy Gustav weighed over 1,300 tons. Its barrel alone was longer than most buildings, and every shell weighed several tons. At what point does size stop being an advantage? That question mattered because size didn't just change what the gun could hit, it changed everything around it. On paper, the logic was straightforward. A larger gun could deliver damage that no aircraft or standard artillery could guarantee at the time. One well-placed round could wipe out hardened bunkers or buried targets in a way nothing else could. But the scale came with trade-offs. Heavy Gustav couldn't move under its own power. It depended on specially laid rail lines, massive crews, and long setup periods just to become operational. Transporting it, assembling it, aiming it, and protecting it all took time and resources. This wasn't a weapon you shifted with the battlefield. Once it was in place, the battlefield had to come to it. Building something this large wasn't just a decision, it was a gamble. And to understand why Heavy Gustav became such a burden, you have to look at what it took just to make the thing function at all. Number 6. Engineering taken to the edge. From a technical standpoint, Heavy Gustav was an engineering achievement. Precision machining at a scale never attempted before. How do you even make something like this work? And this is where the engineering reality really showed. The gun used a massive breech-loading system, custom-built shells, and a recoil setup mounted directly to the rail tracks beneath it. Nothing about firing it was quick. Each shot took hours of preparation, from positioning the barrel to loading and securing the round. Temperature changes affected metal tolerances. Barrel wear had to be monitored constantly. Alignment had to be precise down to small margins, because at this scale, even slight errors had serious consequences. What might be a minor issue on normal artillery could damage equipment or end operations entirely here. It worked, but only when everything was controlled, protected, and planned far in advance. And that brings us to the real test, using it in an actual war. Number 5. Its moment at Sevastopol. Heavy Gustav was deployed during the Siege of Sevastopol in 1942, one of the most heavily fortified positions of the war. But did it actually do what it was built to do? Yes. In a narrow sense, it worked. Gustav was able to destroy fortified positions, ammunition depots, and underground structures that had held up against other attacks. When a shell landed, the impact was immediate and decisive. Entire sections of defenses were taken out in a single strike. On paper, that looked like success. But in practice, the gun could only fire a small number of rounds, and each one took significant time to prepare. While crews were setting up the next shot, the situation on the ground kept changing. Front lines shifted, priorities moved, and targets disappeared. The war didn't slow down to wait for the gun. Quick pause. If you enjoy breakdowns of extreme machines and the thinking behind them, subscribe. These stories aren't about hype. They're about understanding how decisions actually play out. Number 4. A logistical nightmare. For every shell fired, Gustav demanded support on a scale most divisions never saw. What does it take just to keep a weapon like this alive? And this is where the scale of the weapon started to work against it. Thousands of soldiers were assigned just to keep Gustav operational. Engineers handled alignment and maintenance. Rail crews managed the tracks and transport. Anti-air units stayed on constant watch to protect it from attack. None of this effort supported a wider front. It all existed for one piece of equipment. If the front shifted, Gustav couldn't move with it. If air superiority changed, the gun turned from an asset to a liability almost overnight. Its size made it impossible to hide or relocate quickly. The weapon didn't just consume resources. It pulled manpower, time, and protection into a single exposed point that the enemy could focus on. On paper, Gustav could do incredible damage. But wars aren't fought on paper. They're fought with movement, timing, and changing conditions. And that's where the problems started to show. And once the war started moving faster than the weapon itself, the question became unavoidable. What happens to a machine that can't keep up? Number 3. War moved faster than Gustav. As the war progressed, mobility became everything. Fast armor, airstrikes, and flexible logistics. What happens to a weapon built for slow, deliberate warfare? And once the pace of the war changed, the problem became obvious. It gets left behind. Heavy Gustav couldn't adapt to fast-moving fronts. It couldn't redeploy quickly, couldn't react to sudden shifts, and couldn't justify its enormous cost once quicker options were available. While the gun was being prepared or relocated, the fight had already moved somewhere else. Aircraft could strike targets again and again, adjusting as situations changed. Smaller artillery units moved with advancing troops, offering constant support instead of isolated impact. They weren't as dramatic, but they were always present. Gustav belonged to a slower, more deliberate kind of warfare, one that was already fading by the time it finally fired. And here's the twist. Heavy Gustav wasn't useless because it failed. It was useless because the idea behind it was outdated the moment it was fired. Number 2. It could barely aim. Most artillery can adjust aim quickly, left, right, up, down, and respond to changing conditions. But Heavy Gustav couldn't. What happens when a weapon can only aim where the tracks let it? Heavy Gustav had an extremely limited horizontal traverse. To change its firing direction, the entire gun had to be rolled along specially curved rail sections. Aiming wasn't done with controls, it was done with track geometry. That meant targets had to line up with where the rails were laid weeks in advance. If elevation or direction needed adjustment beyond small margins, crews couldn't simply correct it. They had to reposition thousands of tons of machinery along pre-built curves. In effect, the battlefield didn't adapt to Gustav. Gustav demanded that the battlefield be built around it. This turned every shot into a commitment. Once the rails were set, the gun could only threaten what lay directly in front of it, no matter what else was happening nearby. By the end, Heavy Gustav wasn't remembered for what it destroyed, but for what it revealed about the limits of thinking in extremes. Number 1. Why Heavy Gustav still matters. Heavy Gustav matters because it shows how easy it is to confuse raw power with real effectiveness. It proves that even brilliant engineering doesn't automatically translate into strategic value. Winning wars isn't about building the biggest or most impressive tool. It's about choosing something that fits how conflicts are actually fought, day to day. As warfare evolved, speed, coordination, and adaptability consistently mattered more than size. Air power, mobile artillery, and flexible logistics shaped outcomes far more reliably than any single massive weapon ever could. Gustav stands as a reminder that just because something can be built doesn't mean it belongs on the battlefield, or that it will matter once conditions change. Heavy Gustav didn't change the war. It exposed the limits of thinking that believed bigger was always better. If this breakdown clicked with you, check out the video on the channel about the Santa Fe Blue Goose. another machine that revealed where the future was heading in a very different way. And if you want more deep dives like this, hit subscribe. More are coming.